one more thing to remind you guys is next week we have midterm, right? And the week after next, the Tuesday after the midterm, it will be like a programming exam, right? You guys know about that, right? Just want to remind you, okay? Because like I met with one of the TAs, he told me like not too many students show up in the recitation, so I just want to remind you guys about that. Okay. Okay. So back to the insertion, okay, of the red factory. So the insertion is just like first, I mean, you have to find the right place to insert a node. Okay. So at the beginning, it's just like a regular search, just like a regular search. So let's use this as an example. So let's assume we want to search, insert like 15, a new key in here. So so after the you compare with the 7, 15 is greater than 7, so you go to the right hand side. 15 is smaller than 18, so you go to the left hand side. Again, 15 is greater than 10, you go to right hand side. And 15 is greater than 11, you go to right hand side. So you put 15 here. And obviously, every time you insert a new node, the new node will end up at the some leaf node, right? At some leaf node. So you are going to, mark this node red. We are going to mark this node red. Okay. So, of course, like before you insert this node, this is a black node, right? This is a leaf node, but this one obviously is a black node. So after you insert the 15 here, you'll have like a black node. Black leaf node here and here. So, yeah, the black height. The black height is maintained, right? The black height is maintained. So, but the issue with this one, okay, is that there's a property that says for a red node, its parent must be black, right? So this one has to be black. So you have to change this one black. But when you change this one black, okay, obviously, from this node, okay, if you change this one black, that means this branch, the black height increase, right? If you don't change anything here, the black height, will be different on two sides, right? So in other words, okay, you will change the color of both nodes here, okay, to be black. And in order to not affecting this part, the rest of the tree, okay, because if you change these two nodes from red to black, it's better to change this one to be red. Why? Because from here, okay, this one is red, this one is black, then in some sense, like the black height is maintained, right? The black height is maintained. So we'll do this. Okay, but but it's not done yet. Why? You're just moving. Remember, the originally, okay, the problem happens here. The red node, its parent is red. Now, okay, everything is cool, but this red node, the parent is red. So you have like you know, again, you have a violation, okay? But this violation is moving up. This violation is moving up. So what do we do? What we can do is that we can do a rotation. Okay, we can do a rotation. Okay, so we are going to do right rotation 18. So from we move 18 down and promote 10 to here. So it's going to be like this. Okay, this is the rotation that we talked about, right? But after the rotation, okay, 18, its parent, 1810, yeah. So here, okay, so again, we have like, 18th parent is red. So to fix that, you have to change this one to be black. Okay. You can rotate the 7. Okay. Do a left rotation. Promote the 10 to the parent, and then recolor. So it becomes like this. 10 again. It's promoted to the top, to the root. Okay, and then recolor. Okay, so when you promote 10 to here, okay, 7 and 18. Okay, you recolor 10 to be black, and 7 to be red, and then everything is cool. Okay, so let me repeat. First, finish the insertion and rec, and then you need to do recolor. Okay. I mean, if everything is cool, then we are done. But if it's not cool, okay, we do right rotation and left rotation, and then change the color again. I mean, this guarantee that we can fix the problem. So you see, this insertion, because it goes from the top to one of the leaf nodes. This one takes long amount of time. Recolor moving or variation up. This one take constant time, and then right rotation take constant time, left rotation constant time, and recolor again constant time. So the whole thing take log n. Okay, log n. The pseudo code is here. Okay. So the idea, if we use that graphical notation, it's going to look like this. Okay. If the case 1, okay, if there's a violation like this, okay, then we because like this one has to, I mean, the red node cannot have a red parent, so we mark this one red, and this one mark this one black, and this one has to be black too, because otherwise the C there's a problem here. I mean the purple. So we mark A and the B to be black and the C to be red. So when we do that, so the problem for the lower parts gets resolved, but the C becomes red. But the parent of C may become an issue. So we need to go up more to see if there's an additional problem. Okay, so yeah, but if there's no problem for C's parent, so everything's done. Okay, this change, okay, will not violate any property. Okay. Any other property. Okay. So basically, this case one allows us to move the violation, okay, from the lower part to the upper part. And the case two, okay, is that, okay, there's a violation, okay, and then we, the top is C, and if this is the case, we can do a rotation of A to the left and move a B up. Okay. So this will transform to K3. Okay. So the K3 is like the left branch. What should I say? It's like a left right. Okay, this part is there's a violation, or like the other one is like the mirror case, like right left. If this is the case, then we do like the case two. We do the mirror one is do a right rotate. Okay, to make it like the violation is like the left branch or right branch. And then the case three, okay, when you have that, you move B up. Okay, you do a right rotation, okay, to move B up. And then okay, C goes down. Okay, and then A and C to become red, B become black. And at this moment, everything is cool. Okay, after you finish the K3, okay, you don't need to do anything more. Why? Because like all the violation has been resolved like locally, because like the top part is black. So black, no matter the parent is like red or black, it does not go to violate any property. Okay, and the other part like remains like okay. Okay. Oh, by the way, each of these indicate a subtree with black as like a root, as a root of this subtree. Okay. So that's why, like, because these two are black, so when you color the C to be red, it will not create any issue, because the root of these two subtrees are black. So yeah, as I say, like it doesn't violate any property anymore. Okay. And this rotation also guarantee like the black height is maintained, okay, locally. So basically, you go up the tree, perform case one, okay. So it only requires no. If case two or case three occur, perform one or two rotations, and then terminate. Okay. So if case two happens, okay, perform one rotation, and then you need to do another case three, so two rotations. If after the top one, if you see case three, just perform one rotation and you are done. So running time, log n with the search for like where to insert that new node, and all the other operations you have constant number of recurring and rotations, and each of them take constant time. So that's it. And the red metric delete is similar. Okay, you need to do something similar. Okay, basically. Okay, but I will not talk about that here anymore. So please check the textbook for that. Okay. So I'm sorry if I knew like your data structure didn't cover AVL tree. I may, at least spend some time to talk about AVL tree and B tree. But obviously, like I didn't prepare for that. So that's it for this lecture. Okay. So this midterm, okay, will cover everything from the beginning of the lecture to this one. Okay. So that's it for today. Any question? Or do you have any question for midterm?有没有对期中考有什么问题？都没有问题。期中考考好，OK， 好不好 ？OK， 这样校试说都已经准备好了，对不对？啊，没有 ，OK， 好了，加油了，好不好？其实你们知道那个现在学校在讨论那个T分布啊，就是说，因为我们资工系在应该说很多系啊，不要讲就是光是我们系上的问题，应该说很多系都有这个问题，就是分数那个就是被 depreciate 嘛，就是说大家分数都高的不像话，像班上大概排名可能中间的人排名中间的人平均都90多分的，那其实这个不是一个好现象，所以现在那个学校在推那个 T 分布，那我们在那个系会讨论，所以也是我其实在这门课其实有特意把分数就是说做的比较正常一些，所以你们如果成绩稍微比别的科目低一点，其实是正常的，不用太惊讶。说我的科目，我这个是只拿了80几分哦，其实80几分在我们这堂课应该算都高分了 ，OK， 所以也让大家知道说我们并不是，我不会刻意怎么讲，就是说故意用很难的东西，但是譬如说像举个例子来讲，像写程式的这些，我觉得你们应该要会的，那其实我会请助教帮忙来 include 这一块在我们的这个课程里面的这个考试里面，这样子，就是该要有的就是应该要有的，就是大概就这样子，对，先跟大家解释一下啊，所以成绩在我们这堂课，我希望大家不要太，对，如果你要分数高点，说不定另外一个 session 会比较容易拿高。对，我这个 session 本来就是我在开始第一堂课跟大家讲，我们这个 session 分数可能会比较偏低一些，先跟大家讲。OK， 好，那我们今天就先到这边，等于说提前半个钟头，20分钟左右先下课，好不好？那记得同学下礼拜期中考，然后那再下礼拜2有写程式的期中考，写程式的第一次考试，然后再来礼拜3的那个 lecture， 不是我教，我们还是有 lecture， 但是我的博士生会来教，这样子，好不好？谢谢大家。